Chemistry plays an important part in the operation of a refinery or chemical plant. Chemistry is the study of the properties, the composition, and the structure of matter, the changes that occur in matter, and the energy that is released or absorbed during these changes. All refinery and chemical plant processes involve all of these aspects of chemistry. Therefore, a basic knowledge of the subject is necessary to understand what is happening in the various processes. This topic will cover the basic ideas of chemistry and its application to the refinery and chemical plant. Basically, chemistry seeks to identify and classify materials so that this knowledge may be applied to new and better ways of using existing materials and to ways of creating new materials. You are all familiar with similar ways of classifying things from a physical standpoint, so perhaps we should start at that point. Suppose, for instance, you had to classify all the houses in town. How would you do it? You might classify them as to the number of stories, or the material of construction, such as brick, stone, or wood. Or you might classify them according to shape or size, or number of rooms, type of heat, air-conditioned or not air-conditioned. You could probably list many other ways of classifying houses, and you can see that if you set out to do this, you would need some definitions before you started. So let's look at some definitions used by chemists for classification. All materials about us consist of matter. Matter is anything that has weight and occupies space. Your desk, the air you breathe, the water you drink are examples of matter. It may exist in 3 different physical states: solids, liquids, or gases. This brick is a typical solid which tends to keep its shape and volume regardless of where we place it. Solids have a definite shape and a definite volume. A solid does not need side support to prevent it from losing its shape. On the other hand, suppose we pour milk on a table. The milk is not rigid, but spreads in all directions. A liquid must have side support to retain its shape. For that reason, a liquid takes the shape of its container. We find, however, that a liquid has a definite volume when we try to put a quart of milk into a pint bottle. Thus, it can be seen that liquids occupy a definite volume, but take the shape of their containers. When we blow up a balloon, the air takes the shape of the balloon, which is its container. But if we fill an open container with gas, the gas will expand and overflow. So we may say that gases have neither a definite shape nor a definite volume, but will take the shape of any closed container they occupy. Now open your workbook to Exercise 1. Elements are the basic materials from which all matter is made. Elements are substances which cannot be further decomposed by ordinary chemical means. Elements can be further decomposed by nuclear means, but that is beyond the scope of this course. There are more than 100 known elements, and they are the building blocks of chemistry and all forms of life. Elements are the basic materials from which all matter is made. When matter is made up of 2 or more elements, they may be combined chemically into a compound, or they may be mixed mechanically into a mixture. A compound is a pure substance made up of 2 or more elements. Compounds cannot be broken down except by chemical means. Compounds always have the same composition and the same properties. A common example of a compound is ordinary table salt, which is made up of the elements sodium and chlorine. To aid in classifying the thousands of different compounds, chemists have divided them into two major groups: inorganic compounds and organic compounds. An organic compound contains carbon. All of the hydrocarbons which we deal with in the refinery and chemical plant fall into this group. An inorganic compound is one which does not contain carbon. There are some exceptions. We have previously noted that two or more elements may be chemically combined into a compound. What happens when they are mixed mechanically into a mixture such as concrete? In this piece of concrete, you can see that the grains of sand or gravel, held together by the cement, retain their identity and can be separated. Their substance has not been changed in the formation of the concrete. A mixture is a material having no definite chemical composition, which can be separated by physical means, such as boiling, filtering, centrifuging, or distilling. Examples of mixtures are milk, gasoline, crude oil, common soil, and concrete. If we were to take this nugget of pure gold, or any other element, and subdivide it into smaller and smaller pieces, we would eventually come to a tiny particle called an atom. Atoms are the smallest particles of an element which can exist, and still have the properties of the element. Atoms are the pieces that combine to form compounds. For instance, salt is made up of one atom of sodium, which is a metal, combined with one atom of chlorine, which is normally a gas. The compound made of these two atoms have entirely different properties than those of the individual atoms, and this is always the case. A molecule is the smallest particle of a compound which can exist and still have the properties of the compound. In the case of salt, it would consist of one atom of sodium combined with one atom of chlorine. This molecule of salt would be extremely small. If each molecule in a grain of salt were increased in size until it was as big as the ordinary grain of salt, the resulting pile of salt would cover an area of 1,000 football fields to a depth of about 6 feet. Now open your workbook to Exercise 2. We said that atoms are the smallest particles of an element which can exist and still have the properties of the element. Although atoms are too small to be seen under the most powerful microscope, scientists have been able to determine that atoms are composed of still smaller particles arranged in a rather complex way. The major parts of an atom are protons, electrons, and neutrons. An atom consists of a nucleus, which is made up of protons and neutrons, with electrons revolving around this nucleus in what is called rings, or shells. Now let's examine these parts individually. Electrons are tiny, almost weightless, negatively charged particles, which revolve about, or orbit, the nucleus of an atom. Protons are particles 1,850 times heavier than electrons, and have a positive charge. Neutrons are particles having the same weight as protons, but having no electrical charge. The protons and neutrons are packed in the center of an atom and form the nucleus. The atom is electrically neutral, since the positive protons and the negative electrons are equal in number. Each element has a different number of protons and electrons. This distinguishes it from all other elements. This helium atom consists of 2 electrons, 2 neutrons, and 2 protons. This is the lithium atom. You can see that it has 3 electrons, 3 protons, and 4 neutrons. Each element has an atomic number. The atomic number represents the number of protons or electrons contained in an atom. Thus, helium has an atomic number of 2, since it contains 2 protons or 2 electrons. And lithium has an atomic number of 3. We have noted that the protons and neutrons of an atom are grouped together in the center and form what is known as the nucleus. These 2 atomic particles contain the majority of the weight of an atom. The atomic weight of an atom is the sum of the weights of its protons and neutrons. The nucleus of the helium atom contains 2 protons and 2 neutrons. Therefore, the atomic weight of helium is approximately 4. And lithium has 3 protons and 4 neutrons, so lithium's atomic weight is approximately 7. You were told that electrons revolve about or orbit the nucleus of an atom. These electrons revolve according to a definite pattern. Groups of electrons maintain definite average distance from the nucleus, thereby forming what may be called shells. Each shell is capable of containing a definite number of electrons, the number increasing as the distance from the nucleus increases. The helium atom has 2 electrons, and they both orbit in the first shell. The lithium atom has 3 electrons, 2 orbiting in the first shell, and 1 orbiting in the second shell. Now open your workbook to exercise 3.